So the first question is, determine the SI units of K, where R is the radius, V is the velocity, and what is F? F is the force. So I'm going to make K the subject. F is kg basically, meters per second square, that is F. 1 upon meter for R and 1 upon meters per second for velocity. Now I can simplify it. Now S and square cancels out, M and M cancels out. This makes it kg meter second, which is kg meter minus 1 second minus 1. So that should be the answer. Please check if you get the right one. Okay. Now, then use the value of upthrust acting to to calculate the density. So upthrust is rho g delta v. So that's the formula if you don't know. So, well, we don't have volume, so we can find the volume. I think they have given something. Find the value k. Find the value k in SI units is this. Okay. What else you got? This sphere. There is an upthrust acting. There is a weight acting. There is drag force acting. Use the value of upthrust to calculate the density. Okay, so volume is not given. Where is volume? Oh, there is a radius given. Fine. So we can write upthrust was 4.8 times 10 raised to minus 4. Density 9.81. And volume can be found out by 4 by 3 pi. The radius is 2.1 times 10 raised to minus 3 because we want to change it to meters cube. That would be the volume. Okay. Now let's quickly calculate it. If you're comfortable, you can always, do it slowly. It's not necessary to do it like me. So it's 1261, which translates to 1300 for two significant figures. Now, the next one, on the sphere, draw 3 arrows, show the direction of weight, upthrust, and FP. And what else? Label these arrows. Okay. Weight always acts on the center. Upthrust and small arrow for drag as well. Weight and upthrust. Weight should be the largest one, then upthrust, and then drag should be there. So that's you should remember. And did I write drag? I had to write FP. Okay. Uske baad it says determine the magnitude of terminal velocity of the sphere. Determine the magnitude of terminal constant velocity. Okay. Now that's not a big issue. So what you do, you know that weight is equal to upthrust plus F. So we can find FP from this. Weight was 7.2 times 10 raised to minus 4. Upthrust was 4.8 10 raised to minus 4 plus FP. Now this FP 2.4. Now you have this, and now you also know the formula for KRV. We found, I mean, it's given. K is 17. So you put it in. K was 17, R was 2.1. And you got to find B. So that's not something very hard. So V is equivalent to 0.0067. That basically makes it 6.7 times 10 raised to or minus 3 meters per second. Okay, if you have any questions, please let me know. Next, water leaves the end of hose pipe P and with a horizontal velocity. Fine. So with the horizontal velocity means that it has a x component of velocity this and the y component of the velocity is 0. Okay, so the point of angle is blah 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 blah. Doesn't really matter. Explain briefly why horizontal component of the droplet remains constant as it moves from this. So you can always say there is no external force acting in the horizontal direction. If there is no external force, that means it won't change its speed. Show that the time taken for droplet to move from P to Q is this. Now we have horizontal velocity, we have horizontal distance. So for horizontal, there is few things we need to know: displacement, velocity, and time. Displacement is 3.5, velocity is 6.6, I believe. Yes, and time is what we need. So V is equal to displacement. This is the only formula, by the way. Time will be 3.5 over 6.6. That would be 0.53 shown. Pretty easy. Then calculate the height. Now we need vertical height, this h. So we will write for vertical. We have to write SUV at. This is h, this is 0. Final velocity is not known. Acceleration is 9.81. Because it is falling down, the acceleration is also known. So I'm taking it positive. And time is 0.53. We can always take time from, time is independent of these two. So the best equation will be S is equal to UT plus half AT squared. H 0 like this square. All right. So this is 1.4 meters, as you can see. If you have any questions, please let me know. Okay. Now, for movement of water droplet from P to Q, state and explain whether the displacement droplet is less, more, or same along its path. Okay. The movement of water from P to Q, state whether displacement of water is less. It would be less. As it will be a straight line from P to Q. And if you remember O-level, definition, the displacement is the shortest path. How? Because if it's going in this path, but displacement is like this. This is the displacement actually. This means the displacement is the shortest. You can also find this in notes. Now calculate the magnitude of displacement of droplet water that moves from P to Q. Magnitude of displacement, not something to worry about. We know this is 3.5. We know that this is 1.4. So we got to find this displacement. This is 90 degrees. We can use tan. We could use name. Why would we use tan?
Pythagoras tan.
Yeah, we can use that. Pretty good. So you use Pythagoras there. And take under root. 3.8. Pretty good, huh? If you have any questions, please let me know. Okay. All right, going to the next one. It says jet of water vertically right. Okay. There is a horizontal, okay, there is water density cross-section given. Okay, show that over time, 1/6 the mass of water hitting the wall is this. Fine. I think we can do this. So you have the cross-sectional area, you have the velocity. So over 1.5 seconds. So I would think like this, right? I would say what is the distance traveled? Yeah. Show that over, this is the mass, we need to find the mass. Okay. Density is mass over volume, right? Now we want to find mass, so we want density. Density is already given, we want to find volume. Volume is area times length, and length is velocity times time. So let's plug it in. Okay, so density is given as 1000. Area, velocity, time, and this would give us the mass. So let's check whether we have done it or not. Yes, 1.2 kg shown. Please let me know if you did not understand this. All right, now it says calculate decrease in horizontal momentum of the mass due to hitting the wall. If it just hits the wall, right? So its velocity will be 0. So mv minus n. So this is going to be 1.2. And final velocity was 0, initial velocity was 5. So that would be 6 Newton second. And you write 610 please, because we want to write significant figures. Now, the magnitude of horizontal force exerted in water by the wall. Change in momentum over area. Sorry, time. 1.6. That is 3.75. Or you could write 3.8 as well. So that's okay. Then, explain the magnitude of horizontal force exerted on the wall. Same, but in opposite direction. And how do you know? By Newton's third law. Okay. Then calculate the pressure exerted. Pressure is force over area. Force was 6 Newton, 3.8. Area was, I think, 1.5. 1.5. That is 25333. We can write 2.5 times 10 raised to the power 3334 pascals. Is it clear, everybody? Please let me know. Question. All right. Question number 4 now. A child moves from long side. Okay. So kinetic energy here is this. The decrease in gravitational potentially x to y is this. Determine the ratio of kinetic energy of child at y if there is no resistive force, and kinetic energy of this. Acha, if there was no resistive force, right? So I would say, it's my opinion, right? I would just say that it would completely convert the whole. So 300, because it was now there's a resistive force, over 3200 completely. So zero 0.094. Now in ratios, fractions are not allowed. Do not attempt to write in fractions. It would be wrong. And you should always write to correct significant figure. Okay. Please, one moment. All right.
Sir,
Yes.
how is it 0.094? Because it says the kinetic energy of child at y when the resistive force is 76, and then when there is no resistive force.
If there is no resistive force, then all the gravitational potential energy would have converted to kinetic. That's how.
Oh, I see. Okay.
Yeah. All right. Now, use your answer in
Don't you
8.
subtract it?
Why would you subtract it? This is something, the total energy that it had was 3200 GP, right? And if he goes from X to Y, he will have 0 GP. Where is this going? Into kinetic and in resistive force, right? You agree?
Yes.
If there is no resistive force, then this whole will go to kinetic.
Yeah, okay.
Now, use your answer in A to calculate the ratio of speed of child Y when the resistive force is this, and speed of child Y, there is no resistive force. Fine. Not a big deal. I'm going to write half. Basically, this will be half mv square over half mv square. Okay, so they're two different things. The thing is, this is V1, this is V2. The thing is that this is equal to 300 and this is equal to 3200, or this ratio if you want to write it. So we can directly write 0.094 like that, okay? Now half m, because we're talking about the same mass, same person, doesn't matter. So we want to find this ratio, okay? V1 over V2. If we take under root, and take under root. We're going to get the answer. This is going to be V1 over V2 and under root of this is 0.31 like that. Okay, so that's pretty simple. Now calculate the length of slide XY. Now it says find the length. Fair enough. Now you need to understand that gravitational potential energy is going towards what? It is going to kinetic plus resistance. Now this was 3200, this was 300. We want to find this. So resistive will be 2900 joules. Now what you do? Because it is doing work formula is force times displacement, so 2900. What is the force? 76 Newton. And what is the displacement? We'll let, I mean, this is x to y. Okay. So 38.2, you can write 38 only. You can also write 38.2, that's fine. All right. So pretty easy, simple. Now, then it says at the end, y of the child is brought to rest by the board. Okay, I understand. Now, the spring connects the board to a fixed point. The spring obeys Hooke's law and has a spring constant. This, okay. The child hits the board as it moves right and compresses the spring. The speed of child becomes 0. And when the elastic potential energy of the spring has increased to maximum 140, calculate the maximum compression of this spring. It's very easy. Energy, elastic potential energy has the formula half into kx squared. So we want to find this compression. This is 140. This is half. This is 60. We want to find this. So 2 into 140 divided by 63. And x squared be 4.44. And then what you do? Take under root. So this is 2.11. So 2.1 meter would be ideal. Okay, then calculate the percentage efficiency of the transfer of kinetic energy to elastic potential energy. Now kinetic energy, the output was 140, the input was 300 times 100%. That should be the efficiency. So that is 47%. It's pretty easy paper, I believe. Not that hard. Now the maximum compression of the spring is x naught. On figure 4.2, sketch the graph of elastic potential energy and the compression. Now you guys need to understand that elastic potential energy is equal to half kx squared. These two are constant. So energy will be proportional to x squared. So x squared graphs are like this, by the way. And this be 140. Okay. Any questions? Let me know. Now going to the next one, state the condition required for stationary wave. Now stationary wave, well, two waves when meet, right? Number one, same speed. Number two, opposite direction. Number three, same frequency. And number four, same wavelength. These all, if this is the 4 conditions that they meet, a stationary wave is formed. State the phase difference between any two vibrating particles in between two adjacent nodes. If they're adjacent nodes, then always the phase difference is 0. If they're like one antinode and node, then it's always 180. So in stationary wave, either you get 0 or 180. Now motorcycle is traveling this along a road. What a question this is. What an easy. See the pedestrian standing right. So this is VS. FS, F naught, V. Calculate the frequency. So because it is moving towards the pedestrian, so we're going to use F naught, Fs times V over V minus S. This is 543, 334, 334 minus 30. Now let's do it. So my answer for Fs is 521. That would be actually 522 hertz. Because my values were 3 significant figure, all of them. So my answer should also be 3 significant figure, not 2, please, or 1. The motorcycle rider passes the stationary pedestrian, moves directly away from her. As the pedestrian moves away, he operates the horn for a second time. The pedestrian now hears the sound that is increasing in frequency. State variation value the speed of motorcycle when ride operator horn for the second time. If he's moving away and still he's like listening with increasing frequency, then it could only be that the speed of cyclist is decreasing. That would only be the option. Now, going to see. So there's a polarizing filter. I naught, IT, this 20 degrees. I know it is where it is coming from. Say we're considering IT, calculate the ratio amplitude, this. Intensity is directly proportional to amplitude square. So IT over I naught will then be AT square over A naught square. Okay. Now we need to basically somehow find the ratio. Well. Now, how do we do this? I equals to I naught cos square. This is the Malus law. Okay. Cos square 20. Because we know. Right. अच्छा, अब क्या करेंगे? Now, I is the transmitted one. I naught is the incident one. So this will be cos square 20. So instead of these, we can put it here. And root. And this will be cos 20 and power square. So about 0.94. Pretty simple. Now, filter is now rotated about the direction of light beam from its starting position. Shown. The direction of rotation is such that the angle of transmission to the vertical increases. Calculate the maximum angle through which the filter must be rotated so that the intensity of transmitted light returns to the value that it had when the filter was at the starting position. Okay. What is it even saying? I don't understand. Filter is now rotated about the direction of light from starting position. The direction of rotation is such that the angle of transmission to vertical increases. Fine. Calculate the minimum angle through which the filter must be rotated so the intensity of the transmitted light returns to value which it had when the filter was at starting point. Okay, I'll tell you how to do this. But why? Why? Minimum angle. 20 is already there. And if you go like 60 more, like you go like 70 more, that would be 0 because it will be at like this. It wouldn't transmit like. It's vertically polarized. And then you add another 70 like this. It will be like this. This will be 20, right? So plus 70, 140. It will be 140. Now you might be wondering what I've done, right? I'll tell you why. So basically, when you move this polarizing filter like this, okay. So now it is 90. To move it like this, how much more angle do you need? About 70 degrees, right? Now it says we want to bring it like in the same position. How much more would you move to bring it to 20 degrees? Because the next movement is also 90. So you have to move 70 more so that you get 20 degrees rotation, which means that you have to add 70 and 70 together. Is it clear?
No. Could you explain it again?
Okay. So basically what happens is that when the polarization filter is like this, okay? And this is the light going. Okay, so let's suppose this light is like this. Okay, Nusha? So
Yes.
all the light will continue to go. Why? Because if you really look at it, at the transmission axis, this is the light is 0 degrees from it. Do you understand what I'm saying?
Yes.
Okay. Now, because the light, I mean this light wave and the polarization filter are parallel, so the angle they make with each other is 0 degree. Now, let's suppose this is the polarization filter and I move it to something like this. The light is still going straight. Not like that. Okay. Now the filter is like this, okay? The issue with this is that when the light is going to go from here, basically filter is like this. When the light is going to go here, you need to understand that with this transmission axis and the light, the angle was 20 degrees. Do you understand?
Yes.
If I keep on rotating it such that it becomes horizontal, the light is vertical, but the screen is horizontal. So now with the transmission axis, this is the transmission axis, it is 90 degrees. So at 90 degrees, you have 0 transmission. Do you understand?
Yeah.
So when the transmission axis is exactly, let me change the color, like this. So it will be 90 degrees, right? So how much angle do I need to move for it to be 90 degrees? 70 degrees? What do you say?
Yes.
Okay. Now it says we must rotate it so that the intensity of transmitted light returns to the value. How can we return it to the value? We can only return it to the value if the angle with the transmission axis is again 20 degrees. Do you understand? So I'm making another color. So 20 degree means this 20 degrees. Do you understand? Now you have to keep on rotating it. You have to bring it here so that this angle again becomes like the wave and the transmission axis is 20 degrees. Do you understand? If I was at 90, how much do I move? More. This total is 90. 70. Do you understand?
Yeah.
So 70 and 70 I've moved. So how much is this? 140.
Yeah. Okay. 140. Yeah.
Do you understand? This is the trick. So this was a tough question. I hope you guys understand this. So you guys need to understand that at 90 it is 0, at 0 it is maximum. So you keep on rotating. One of the ways I'm thinking right now was that if I ever want to get to the same angle, like if there was 20, I want to get to 20. So I'll just, I will just do what? I will rotate to 180. 180 means that you have moved like half of it and then subtract that angle twice. That would also give me this same answer like that. But that's up to you. That's okay. Okay, now 6. The power dissipated by resistance is 36. Calculate the current. There's an EMF also. Power is VI. This is 8. So 36 divided by 8 is 4.5. The number of free electrons that pass through resistance wire. You have the current. Q is equal to IT. 4.5 times T. So the total charge passing is 50 coulombs. Now it says number of electron. One electron is 1.6 times 10 raised to minus 19 coulomb. You should know this. And how many electrons will be in 225 coulombs? Cross multiply. 225 divided by so that is 1.4 times 10 raised to power 1, 2, 3. 20 plus 3 is what? Minus 20 QR. Oh no, my bad. See, mistake here. Divided. Oh god. 1.4 times 10 raised to 21 electrons would go. Now, the resistance of the wire. Pretty simple. You can use power is equal to I square R. Power is 36. R. In case you miss one part, you can still do it with the other values. So don't panic. That would be 1.8 ohms. Okay. Pretty straightforward. Now, the metal of resistance wire in the circuit is resistivity. The cross-sectional area. Determine the length of the wire. Okay. Resistance is rho L upon A. We just found the resistance, I believe, 1.8. Resistivity. We want to find length, and cross-sectional area is this. Now 0.25. Now this is in millimeter square. That's a big issue because 1 millimeter is basically 10 raised to power minus 3 meters. if I want to find area which is square, so I have to square it. So 1 millimeter square is basically 10 raised to minus 6 meters square. I'm going to do 10 raised to minus 6. That's the only catch here. Okay. What did I do? 2, 5. Okay. So the length is 0.
Say 1.4, not 1.5. 1.4 times 10 to the power of minus 6, not 1.5 times 10 to the 10 to the power of minus 6.
Oh, okay. ठीक है. 0.32. मुझे रोजा लग रहा है actually. Too sleepy. That's fine. You are a circuit charge. The circuit shown in the figure is modified by replacing the original resistance with the second wire. The second wire has greater diameter, and there is no other differences between second and original wire. Okay. State by reference resistance, state with the power dissipated by second wire is more, less or same. First of all, I say greater diameter, hence greater area. Okay. If there is more area, so less resistivity. Okay. So now you basically get the
So
same.
could you go back for a second and show what you did on the calculator?
Yes.
So you forgot the wait, what?
That's my habit of doing, like, I don't put brackets.
Oh, never mind. Okay, my bad. Yeah,
You
sorry.
have to put brackets if you don't remember what I do. Okay.
Yeah,
Now, the same potential difference and greater current, because the current will be greater as the resistance is less resistance, not resistivity. So greater current means, according to power equals to VI, more power dissipated. So that should be written.
Why is
All
the
right.
current greater?
Because the resistance reduces. Resistance is not really fond of current. That's fine.
Yeah, okay, yeah.
All right. Now, then part D. Now it says the circuit is modified. Second battery of EMF is in parallel by reference to current, resistance, and this. First of all, I would like to tell you that it's the original wire. Current remains same. Because adding a extra battery in parallel does not increase potential difference. Okay, should always remember that. Since voltage and I remain same, hence according to power VI, power is same. So your reasoning should make sense, please. Make sure you always write cohesive, like comprehensible, something like that. Now, state the name of another lepton that is produced by beta positive. electron neutrino, right? These are easiest. Given nuclear number, proton number, nucleus that is formed by this decay. Sodium 22 decays forming something plus beta positive plus electron neutrino. This is 0 and 0. So 22 on the top line, this will be 22. Bottom line 11 equals x plus 1 plus 0. That has to be 10. So the proton number here will be 10. This will be 12. Pretty simple. The core composition of nucleon in sodium 2,2 nucleus is changed during decay. Describe the change. So you should remember that whenever this goes up, quark always changes to down in beta positive, and happens the other way around for beta negative. A baryon consists of quarks that are same flavor. The charge of baryon is -2e, where E is the elementary charge. Okay, so calculate the terms of in terms of E, the charge of each quark. Okay, so for getting 2 by 3, we must get -2 by 3, -2 by 3, and -2 by 3. There is no other way. So this we will end up with -6 by 3, which is -2. So we have to write each charge should be -2 by 3. State the possible flavor type of quarks. Okay. So anti-up, anti-charm, anti-top. Anything can work actually. Okay.
Sir, wouldn't the nucleon number be 22?
Nucleon number? Oh, nucleon number pucha hai. Sorry. You're right. 22. I'm too sleepy. Honestly, I'm too sleepy. I actually fell asleep during a calculation. वो जो हो गया था ना 1.5. It was not intentional. It was like I slept. Wow. Okay, you guys understand everything? Any questions?
Yeah, on
I
page
think-
6, could you do the last